Hi, my name is Gizem Ateşvenos and I'm going to present you the robotics courses that we have at Western Norway University of Applied Sciences in the Department of Engineering in Automation and Robotics. The first course is ELE 207, Control Theory and Mobile Robots, and the second one is ELE 208, Robot Manipulators. First, maybe we can talk about why we have those courses in our study plan. There are several reasons, but I would like to highlight just some of them very quickly. The first is those courses will cover advanced robot control systems, sensor integration, machine learning algorithms, which are essential for developing smart automated systems, and this is important for you as an automation engineer. Second is that robots becoming increasingly relevant in industries ranging from manufacturing, logistics, health sector, service robots, etc. And there is a huge demand for automation engineers with adequate robotics knowledge. So it will increase your value as an automation engineer by knowing the robotics as well. So the next is the relevancy to research. As an academics, I think it is very important because robotics is a rapidly evolving field that has significant research potential. Soft robotics, human-robot interaction, deep learning, and those sort of subfields within robotics, they need a little bit more investigation and many more than that we don't have to count all. So students who are interested in pursuing an academic career or working in research and development kind of positions in the industry can benefit from early exposure to a robotics course. And finally, robotics involves lots of integrations of sensors, actuators, and different components, and it handles how we can merge them and make them work smoothly and nicely in one system. So these courses will increase your system integration skills. And how we achieve to meet those highlighted reasons and relevance? Well, there will be lots of modeling and analyzing of different robots. We will do lots of programming and algorithm developments during the lectures and through the assignments and laboratory exercises and semester projects. So you will get a good grasp of different actuation mechanisms, sensor types, how to integrate them, and then how we can get this data and process it and use it into our benefits. Those are something that you will be learning throughout those courses. You will learn about different navigation, localization, and mapping algorithms. And at the very least, then you will understand your robot vacuum cleaner at home when it works and when it doesn't work that well. And of course, we will learn lots of theory about robots and robotics, but theory will be the skeleton of our robotics knowledge, but we will enhance our skills through practical assignments and the projects. You will take 2 courses related to robotics in your bachelor study. Both of them have 10 study points. The first one will be on your 4th semester and the second one will be on your 5th semester. The first one will be more about mobile robots merged with your control theory course or reguleringstechnique, since there are a lot of common concepts. You will or already have been in the session that covered the control theory part more in depth, so I will focus more on the robotics related part of ELE 207. There will be an introduction to robot kinematics through mobile robots in that course. For those who are unfamiliar with the word or the term kinematics, it can be defined as the way to mathematically model the robots and in terms of how they move, where they are, and how their state is now or will be in the future. And getting familiar with the robot types and their structure, how they navigate and locate themselves in a given map, or how they even generate a map and follow a path will be the subjects of this course. On the other hand, you will have a deeper look at robot kinematics in ELE 208. You will learn about how to mathematically model a robot arm, how to design and program one, and how to control it. As in mobile robots, there are different types of robot arms as well. So it is very hard to know the exact number of how many robots are installed in different industries at the moment. But we have a report, 2024 report of Industrial Federation of Robotics. And in that report, it says there are 500,000 newly installed units in 2023, on top of over 4 million industrial robots that are already operating today in the productions. And you can imagine that not all those robots are identical. There are different robots and different structures and do different tasks, and they are beneficial for different purposes. So you will be learning about different types of manipulators and how they plan their trajectories in this course. And in both of those courses, we will heavily use MATLAB, ROS, and Python in our hands-on exercises and during our lectures. In addition to the different simulated robots in those platforms, we will often use the Turtlebot, the one that you see on the left, as our main physical mobile robot, and also in the ELE 207. And also we will use the universal robots in our ELE 208 mobile robot manipulators, ELE 208 robot manipulators course. However, our lab is equipped with different types of robots and sensors, so you will have an opportunity to test and develop other fancy projects in your semester project, let's say. Let's have a quick look at the content of ELE 207. What we often deal with when it comes to mobile robots is where they are and how they go to where we want. We define some reference points and we observe and calculate how those frames get closer or further away from each other. Also, we are dealing with how exactly they generate a nice motion. For example, a Husky robot uses 4 actuated wheels and can go over harsh terrains, moves like a regular car, if you will. However, it cannot rotate around itself. It should follow a circular path, as we call. If we have another type of structure, a mechanical part, let's say different types of wheels, even if it looks like a similar robot, it can be completely different robot in terms of kinematics. Then you can do more holonomic motions. It means like you can move in any direction independent of its orientation. It doesn't have to be a four-wheeled robot. It can be a single ball like actuated mechanism. It will be very well a mobile robot, or a flying or swimming robot, also considered a mobile robot. So you will be familiar with all those robot types and their kinematics. And it is also important to locate where these robots, the mobile robots, are with respect to, let's say, a fixed camera or a point on the map, let's say where we sit with our PC. Similarly, it is equally important where an object is located with respect to the robot. It can be an obstacle not to hit when the robot goes autonomously around, or it can be an animal or a human that we don't want to crash and not to hurt. All those are about autonomous navigation, localization, and mapping. What about the path planning then? So to do that, there are different types of path planning algorithms, such as D-planners, such as probabilistic road maps and lattice planner, and so on. So you will have a good understanding of different algorithms to choose where and how when it comes to a particular task. And you will excel at most relevant algorithms, I would like to say, using MATLAB, ROS, and Python. Throughout the semester, you will design, simulate, and control your mobile robots, starting from the simplest structure to the more advanced ones, such as a boat or a plane or a drone. And finally, you will have a chance to test your algorithms on real robots. All right, has anything left for robot manipulators? Yeah, more than probably you wish for. So in this course, you will have 10 study points only on robotics. So the introductory concepts that we had in the previous course about modeling and design of a robot will be covered much more in depth in this course. So for instance, this is how we roboticists see when we look at an industrial robot arm, where the joints are and what relation those joints have with respect to each other. Because when it comes to robot manipulators, we are not very much interested in where our robot is. It is mostly fixed to a place. But we are more interested in where the hand or the end effector of the robot is and how it moves and how it generates the motion. So the motion and the reach of the end effector, or where you are able to do things with this robot, is very much linked to how those joints are located and how they have the relation with respect to each other. So we will both theoretically calculate the things, but also practically simulate and observe how our robot behaves or looks like based on the design criteria that we choose. These are just some simple assignments done by our students during the former version of this course. So on the left you see a pick and place task, and on the right you just saw a machine tending task. But we will have more depth exercises that can be used or influential about other types of robot arm tasks, such as welding, assembly, painting, inspection, and so on. It is also important to note that just determining the position of the end effector is never sufficient for pretty much any of the robotics tasks. It is also very important how the robot moves to the desired end effector position, how smoothly it follows the given path or the desired path. So there we start with the manipulator velocity and the trajectories and tool path planning. For instance, you may need to follow a circular path for a polishing task, and how you do it so smoothly is a thing that you will learn in this course. To define the task path, if all points in the path are reachable, if your robot can achieve the task, how quickly, how smoothly it can do, the way how the joints move to create the desired path of our end effector, all will be covered in this course, again both theoretically but also practically. Well, I actually realized that I start using a little bit too much of the technical terms, so let me just wrap up. Here is the research group behind the design of these courses, tailored them into the industrial needs, maybe the research needs, and prepare the lectures, organize the fun activities, and maybe a little bit scary assignments. No, I'm just kidding. I genuinely believe that you will both have fun and gain valuable skills throughout the courses. If you have any questions, please send an email to Eric, who is the course responsible. And yeah, we are looking forward to meet you.